Okay. The next statement, each project is managed by one professor. Each project again, and here the relationship, there is a relationship between professor and project, and that is the relationship name is works on. But from this statement, and we can say that there is another relationship between project and professor, and it is the menace. Okay, means the professor is going to be acting as a manager for the project. Okay, so there is going to be two relationship between professor and project between so okay, so this is the next, professors can work on multiple projects. So this statement gives us the uh, means the participation means participation constants, and means it will give you the cardinality ratio and particip how much participation the professor is going to do on the works on relationship. So this statement gives you the that particular information. The next thing is students has SSN name and a degree program. So this gives the attributes of the students entity type. Okay, students has means the attributes is going to be SSN name, degree, and this degree program. The last statement, students have one major department in which they are working on their degree. Students have one major department in which they are working on their degree. So students is going to be, means this gives the relationship between the student and the department in which they are doing their degree. Okay, major department. So we see some, means we found out from here, we found out four entity types: department, professor, project, and student. Okay, and the relationship between department and professor, and then professor and project, there are two types of relationship between professor and project, we already know that. And then there are relationship between department and student from this the last statement. And again there is another relationship between student and project. Okay. Okay, now let us just try to go through the statements one by one, and let us try to design. So here you can see these are the entity types and the attributes we identified just now. Okay, let us design it together. I'll give you 5 minutes, and at the same time I'll just show you what will be the this one, what will be the entity types and the relationship type. You do the same thing and you can send it to our WhatsApp group. Okay, so these are the entity types and the attributes of the entity types. The first one is department, and from this statement from here, university is divided into department which has department number and department name, isn't it? So department is going to be the first entity type with the attribute department number and department name. So that is why we are having D number and D name. So for each entity type, we have to select one key attribute, one key attribute which will be used to uniquely identify the entities, isn't it? So I have chosen this department number as the key attribute for the department entity type. Okay, and then from this statement, department has professor. So we know that there is going to be another entity type professor, and the attributes will be something like this: SSN, name, age, and research specialty. So for professor will have SSN, name, age, and research specialty as their attribute. Okay, so and again you have to choose or more one or more attributes as a key attribute. So I have chosen SSN as the key attribute for the professor entity type. Okay. Okay, so after that project, so again another attribute, another entity type is here with its attributes, project number, starting date, ending date, and budget. So this is the third This is our third entity type project with project number, starting date, ending date, and budget. Okay, P number is the key attribute. Okay, after that, and from here again, we know there is going to be another entity type keeping track of the student entities, isn't it? So it will be, we will have student, and from this statement, and we got the attributes of the student entity type as SSN, name, and degree program. So it will have SSN, name, and program in which they are doing their degree. Okay, so SSN will be the key attributes. So these are the entity types and their attributes, and the relationship that we have identified. Let us just write it down here. University is divided into departments, which has department number. Okay, department has a professor who runs the department, so there will be a relationship between department and professor, isn't it? Department and professor, and I will name it as runs. Okay, and it is between department and professor. Okay, department and profession. Cardinality ratio will be 1:1. It is going to be 1:1 because one department, one professor is going to run it. Not more than one professor will be running a department. Okay, and
Ma'am, it's ER model we have to draw now or after the class.
you can draw it now also if you are able, means if you are already know whatever information is given, then you can analyze it. If you have done analyzing it, then you can draw it. Okay,
Okay,
now
ma'am.
now
We will send after class.
uh yeah, you do it now. Okay, because I'm going to show the same thing now only.
Okay, ma'am. Okay.
Okay, so runs will be the cardinality ratio, it will be 1:1 because for a department, for a single, means for a department, you have to do some assumption. I told you yesterday what actually is happening in real life. You have to do the assumption, isn't it? So for a particular department, there is only one professor who will be running the department as a HOD, isn't it? There can't be two or more HOD. So it will be one, and from again a professor, the HOD will be managing only a single department, isn't it? They can't be working on different departments. So it will be 1:1. This is very obvious. And the participation constraint runs from department side. Tell me what will be the participation constraint? Anyone?
Ma'am, can you repeat the question?
What will be the participation constraint for department in the run relationship type?
Uh, will it be total?
Yeah, it will be total. Okay, will be total because yeah, we know that for every department, when we see in it is a university department, sorry, university database. So departments will sure be having a professor who will be acting as the HOD. Okay, this is for sure. Department, for every department there is going to be an HOD. So it will be, department will be total. But from professor side, what will be the participation constraint?
Ma'am, partial.
Yeah, it will be partial because all the professors are not going to be HOD, isn't it? Only some of the professor will be participating in this relationship type runs. So that is why it will be partial. Okay. Now we have already identified the first relationship, and it is between department and professor from this second statement. Okay, so now let us see what other relationship type we can find out from here.
Sorry for interrupting, ma'am. Few students are trying to enter the class.
Huh? What?
Few students are trying to enter the class, ma'am.
Hmm. Try to enter the class means it is already 1:20, and You are too late.
Ma'am,
Okay.
she's trying from 113, ma'am.
I haven't got any request for now.
She even have the screenshot, ma'am. She's sharing ma'am isn't accepting a request.
Okay. Tell her that I am not getting her request for now. Okay, just uh means let us come to the to our lesson. Mm, this is means it is giving a lots of distraction to our lectures also. So that is why I told you to enter the class just 15 minutes, means before 15 minutes we start the class. Or even you can enter, means I entered the class 5 minutes before we start the class, means I always entered at 12:55, and you people just waiting for 1 p.m. and then after that you are, I don't know what you are waiting for. This is a lot of means disturbance. It is creating a lot of disturbance to whatever I'm explaining to you. I can't I can't allow them to enter now. So where were we? Okay, so we have the first relationship type. We just identified the first relationship type and uh, their coordinate ratios and participation constant. Okay, so some group of professors and students work on each project. So you can, here you can create two binary relationship type or a single ternary relationship type. Okay, if it is a ternary relationship type, then and there won't be any coordinate ratio, means you can't have coordinative ratio, but there will be participation constant. Okay, and this binary sorry, this coordinated ratio is defined only, we can define it only for a binary relationship type. So let us for now let us just focus on the binary relationship type, and we can, from here we can identify, means we can create two relationship. Type one is between professor and project, and another one is between students and project. So between professors and project, I will name it as works on, and between students and project, I will name it as works in. You can give the name as whatever you want, but for now I'll give it like this. I'll keep it like this. So works on is between project and professor. Okay. So project and professors works on. Let us read the statement again. Some group of professors and students works on each project. So it means there is no such thing that is given here that a professor can works on many projects. Yeah, professors can works on multiple projects. Okay, and okay, students, for students, it is not mentioned, isn't it? And let us focus on works on first. After that, we'll go to the works in. So professors works on many multiple projects, isn't it? Some group of professors, and again, some group of professors are going to be working on the project. So what will be the coordinated ratio for works on?
M is to N.
Yeah, it will be m is to n. Okay, and participation constant for project, it will be total. We can do the same assumption we did in previous class. And from professor, there might be some professor who are not working for any project. Okay, just keep it total. It is you can assume anything here. Okay, if it is not obvious, if if you can't find anything, any information, any participation constant from the given requirement specification, then you can you can just guess the participation constants or even the cardinality ratio also if it is not given. Okay, so then after that for works in, the participation is participating entity types are project and students. Okay. And cardinality ratio, again, I will give it as n is to m. Okay, because it is not mentioned here. Again, it is mentioned some group of students works on each project. So it is mentioned for the student side, but for project, it is not mentioned anything. So we'll give it as n is to m. Again, let us assume it as total participation from project, and for students also it is total participation. Even for from student side, it can be partial also, isn't it? Some students might be there who doesn't got any project to works in. Okay, so it might be partial. You can give partial participation constant for the students student entity type. Okay, for the relationship works in. Okay, these are the relationship type we have identified so far. Let us see whether we can have other relationship type or not. Each project is managed by one professor. Again, there is another relationship managed which is between project and professor. And it is between project and professor. So each project is managed by one professor. It is 1:1. Okay. From project side, it is total, but from professor side, let us partial. Okay. Each project is managed by a one works on. Okay, professors can works on multiple projects. This we have already done. Done. I mean, we have already represented it in the works on relationship type. And students, and then students who have one major, okay, one major department in which they are working on their degree. Okay, so another relationship can be identified. We can define another relationship from here. Let us name it as measure, and it is between student and department. Student and department, and it will be from real life. We can say that it is 1:, sorry, n:1. It should be n:1. Means for a department there can be many students, isn't it? But for students can be measuring on a single department. So it will be n:1. And for participation constant, it is total from student side, and for department also it is total. Okay. Is there any more relationship type? No. So we have identified 4 entity types with its attributes and 5 relationship type with its participation constants and cardinality ratios. Okay. So I have given a rough means here. I already identified all of them. So these are the okay. So whatever we have done here, according to that, you draw the entity relationship diagram. It may be different from this one because I've done it way before getting to this particular lecture. Okay, so if there is anything different, then you just use this information and draw the entity relationship diagram. It might be different from here because there might be some difference in the assumption I have done while designing this particular ER diagram. Okay, I think I got some of the ER. Okay, draw the ER diagram according to whatever information we got from here, from the requirement specification. I have already collected the important information, and we have already identified whatever things we need to identify, isn't it? So by using these things, just draw the ER diagram and send it to our WhatsApp group. Okay, I'll give 5 minutes. Do it. Send it to the WhatsApp group. Just don't copy from here, this one. It might be different. Okay, there might be some different between whatever assumption we have done here and this with this ER diagram. Try to, all of you, try to participate in this classroom activities, because in your assessment there is a point called this one, conduct. So whoever is going to actively means you just try to actively participate in the classroom activity, whether it is means whether whatever answer you are giving is wrong or right, it doesn't matter. So how much you have participated will count. Okay, just try to participate. Okay, let us see another example. Hostel mess database. So the requirement specification that is given here is somewhat different with the requirement specification we have seen so far. Hostel mess database keeps track of all the available hostel mess menu, warden, and and student details. Excuse me. So for the hostel mess database, here according to whatever is given here, what we have to keep track of the details of hostel mess menu, warden, and student, isn't it? So we can have this, we can create, means we can have all of them as an entity type. Hostel as an entity type, mess menu as an entity type, warden as an entity type, and student as an entity type. And another thing is, another way of representing is this maze menu. Maze menu, this can be, we can use it as a attribute for the hostel also. Okay. If it is, means if it is not required, if it is no further details is required for the maze menu, then you can keep it as an attribute for the hostel also. Or in another way, you can represent it as a entity type. Okay, let us read out the other things. Each hostel has a unique number, name, and type of hostel, which give information about whether the hostel is for girls or boys. Okay, so these are the attributes for the hostel. So hostel will have a number, name, and type. Okay, three attributes: number, name, and type. Okay, and in this this type, the value for this type can be either girls or boys. These are for the values that will be entered for the entities that will be entered for this particular hostel entity type. So for now means we are just designing ER diagram, isn't it? So whatever information we are going to enter to the database, it is, means we do not need to, it is not necessary for now, because we are just using the ER diagrams to model the particular database. Okay, so this are going to be the value. So we will be using this information while creating the database. Okay, so for now, just skip this thing. We do not need to know what information will be entered to the particular attribute type. Okay, so it will be having three attributes: number, name, and type. Three attributes. After that, let us see the next statement. Keep track of the mess menu of each hostel to record in which day what special dishes are given for breakfast, lunch, and dinner. So from here, I told you that there are two possibilities. One is representing mess menu as an entity type or a mess menu as an attribute. If it is represented as an attribute, then from here we can see that it is going to be a composite attribute. Okay, because for a particular hostel, there is going to be many values for breakfast, lunch, and dinner according to the day. Okay, so it will be multi-valued, because for Sunday it will be different, for Monday it will be different, for or Tuesday it will be different. So it will be having multi-values. Okay, it will have 7 values. Okay, and again, why composite? It can again break break up like this as a sub attribute. Okay, means sub part. The sub part for the mess menu is going to be breakfast, lunch, and dinner. Okay, so if it is represented as an attribute, then it is going to be a multi-valued attribute. Composite attribute, multi-valued and complex at the same time. Oh, sorry, it is going to be a complex attribute, composite and multi-valued at the same time. Okay, and if it is represented as an entity type, then what will happen is there is going to be a relationship between hostel and mess menu. Okay, and for mess menu, the attributes are going to be breakfast, lunch, and dinner. Other than these three, just put another attribute as number, serial number, or whatever. Okay, and whatever possible combination of breakfast, lunch, and dinner will be given as a value for these three. Okay, and this one, day, day, this day, in which day what particular special dishes is going to give depends on the hostel, and this depends on this hostels also, isn't it? So just keep this day as the attribute for the relationship between the hostel and the mess menu. Okay, keep it as the attribute of the relationship between hostel and mess menu. Okay, so that is it for hostel and mess menu. For the other entity types, warden, student, no information, no more means nothing is just given here in the requirement specification, isn't it? So you have to do the assumption, and for warden, just give some few attributes like warden name, qualification, like that. Okay, just give some information about the warden for the warden entity type, which will be defining the warden. Okay, and that will be the attributes for warden. And a student, again, same thing. For student, you can give as an attribute, as the attribute of the student entity type, name of the student, enrollment number of the student, department of the student, sex of the student, like that. Okay, just give some few attributes to the student entity type and some few attributes to the warden entity type. And again, nothing is given here, but still we know that there is going to be a relationship between hostel and warden. Okay, just give a relationship type between hostel and warden, and there is for sure, again, there will be a relationship between hostel and student, isn't it? So there can be a relation, means a requirement specification can also be given like this. Okay, if all the informations are not given in the requirement specification, then and you have to do some assumption according to the real life means whatever is happening in the real life, in our real life. Okay, so there is going to be 4 entity types or just 3 entity types for this database, and a relationship between hostel warden, hostel student. Two relationship type if mess menu is represented as an attribute. If mess menu is represented as an entity type, then there is going to be 3 relationship type. Okay, one is between hostel and mess menu, another one is between hostel and warden, and other thing is hostel and student. So all of them are related using the hostel entity type. Okay, indirectly warden and student is also indirectly related using the hostel entity type. Do it as a homework and you can submit, means this is not an assignment. As an assignment I will give a different thing. Do it as a homework and you can submit it today itself in the WhatsApp group. Submit it today itself. Okay, from the next class we'll start another topic, and that is relational model. So till now, if you have any doubt, then you can tell me. Any doubt? For the previous database, you can see this slide also. Whether it is correct or wrong, you can see it from here. Okay. There is means coordinated ratios are not mentioned here. Okay, I'll give you the correct ER diagram later on after the class for this particular example. Okay, then response your attendance. Abhijit,
Present, ma'am.
Akash,
Present, ma'am.
Atul Sharma.
Present,
Atul
ma'am.
Sharma.
Present, ma'am.
AR Sorenchoi.